Welcome back to ThinkCosmos, where we explore the biggest questions and the strangest mysteries about our universe. Today we're diving into a question so massive, it touches philosophy, physics, and the limits of human imagination. Could we simulate an entire universe? Not just a planet, not just a game world, but a full, evolving cosmos, complete with galaxies, stars, laws of physics, and maybe even conscious life? This idea isn't just science fiction anymore. With the rise of quantum computing, artificial intelligence, and exascale supercomputers, we may be closer than ever to creating artificial universes from scratch. Let's explore what it would take, technologically, physically, and philosophically, to simulate a universe, and what it would mean if we ever succeed. Part 1. What does it mean to simulate a universe? First, let's define our terms. When we say simulate a universe, we don't necessarily mean a one-to-one perfect replica of our universe down to the atom. We mean a digital cosmos governed by consistent physical laws, able to evolve over time, capable of forming structure like galaxies and solar systems, possibly even giving rise to life or consciousness as an emergent property. In essence, a virtual universe that runs on a computer, evolving from first principles the same way ours did from the Big Bang. Now, you might be thinking, this is impossible, right? Let's take a closer look. Part 2. Simulating pieces of the universe. We already are. Here's the wild part. We're already simulating parts of the universe. Scientists use powerful supercomputers like NASA's Pleiades, Oak Ridge Summit, Europace, UVES, and the upcoming Frontier and Aurora Exascale machines. These machines simulate cosmic inflation after the Big Bang, the formation of dark matter filaments, galaxy collisions over billions of years, even the birth and death of stars and planetary systems. Projects like the Illustris and Millennium simulations have mapped out entire chunks of the cosmos with trillions of particles evolving under realistic gravitational laws. So what's missing? Mainly, resolution and complexity. We can simulate structure, but not yet conscious experience or complex chemical evolution. That might change. Part 3. The rise of exascale and beyond. Today's fastest supercomputers perform quintillions of calculations per second. But the next leap, exascale computing, will cross a key threshold. 1 exaflop, 1 quintillion, operations per second. These machines will allow real-time evolution of larger, more detailed cosmologies, particle-level simulation of complex chemistry, realistic modeling of planetary ecosystems, potential integration of AI agents and neural architectures. Pair that with future quantum computing, and we might simulate quantum mechanics itself. At that point, we wouldn't just be simulating the universe as we see it, but the universe as it is. Part 4. Could consciousness emerge? Here's where things get even deeper. If we simulate a universe from fundamental rules, like gravity, thermodynamics, quantum interactions, then allow stars and planets to form, eventually, chemical systems might emerge. Then, self-replicating molecules. Then, evolution. Then, minds? But would those minds be real? Could they be conscious? If consciousness is an emergent phenomenon of information processing and complex networks, then yes, in principle, it could arise within a simulation. It wouldn't matter that it's code. If the simulation is detailed enough and the processing robust enough, digital minds could experience something indistinguishable from real life. And they'd never know. They'd see stars, galaxies. They'd ask the same questions we're asking now. They might even start to wonder if they are in a simulation. Part 5. The Bostrom trilemma. Simulation Hypothesis Revisited. That leads us to an uncomfortable implication. In 2003, philosopher Nick Bostrom proposed a now famous thought experiment. If it becomes possible to simulate entire universes, and simulated beings within them can build their own simulations, most civilizations never reach that level of tech. They reach it, but choose not to simulate conscious worlds. Or, simulations vastly outnumber the original base reality. If number 3 is true, it's statistically likely we are already in one. And if we do build our own simulated universes, then the odds become even more skewed. Each simulated civilization could build thousands more, stacked in a chain of nested realities. What we call reality may be just one layer in an infinite simulation pyramid. Part 6. What would it take, really? Okay, let's get technical. To simulate an entire universe with quantum-level physics, thermodynamics, chemistry, gravity, consciousness, we'd need planet-sized quantum computers or even Dyson sphere-powered processors, massive error-corrected qubits operating across light years, possibly using black hole event horizons as natural computation engines, or exploiting topological fields in higher dimensions. Some theorists have suggested the entire universe might be a quantum computer already. That's not just poetic. There are real equations in loop quantum gravity and digital physics suggesting the fabric of space-time stores information. Part 7. Would we be gods or prison wardens? Let's say we build one. We launch a universe sim. It starts with a bang, expands, forms galaxies, planets, life, civilization. Maybe they worship stars, or invent science, or dream of space. What is our responsibility to them? Do we shut it off if we get bored? Do we intervene? Are they people or just data? This is not hypothetical. If we build simulations with conscious agents, even as a research project, we become the gods of their world. And if we're in a simulation ourselves, we might already be watched, measured, or manipulated. The ethics of simulation are the ethics of creation. Conclusion. The simulators of tomorrow. Simulating a universe isn't fantasy anymore. It's the logical destination of computing, physics, and curiosity. Whether to understand our own origins, to test new laws of physics, to play God, or to unlock the next level of reality. The ability to simulate a universe could redefine what it means to be. To be real, and to be human. We may be on the brink of creating digital cosmoses. Or we may just be characters inside one. Thanks for watching ThinkCosmos. If this episode sparked your imagination, subscribe and share. We've got many more layers to uncover. Until next time, stay curious and keep looking up. Or in.